Hey all, welcome back to my channel. In this video, we are going to understand very important types of number system, which as a network engineer you should be aware of, not or even aware of. You should understand how to convert them. Not and this will be helpful for multiple exam as well as practically when you see things going around you. For example, IP addresses, MAC addresses, and IPv6 nowadays they are in hexadecimal. We need to understand how things are addressed, and so we are going to we utilize all types of number system in that. So our computer program understand only binary numbers, which are zeros and one, and it also understand our decimal number by converting them into binary, and also hexadecimal by converting them into binary. So how a computer understands binary code? Each bit has a single value of either 1 or 0, which means it can't take any other value. Computer understand represent number using binary code, which are zeros and 1 as I explained. And our CPU and the RAM and other chips understand either something is on. If it is on, that means it is 1. If it is off, that means it is 0. How a computer understands hexadecimal number? So here it has written hexadecimal number commonly used in computing because it can represent a byte of data with just two characters. So it reduces the work done by CPU by understanding it in terms of nibbles, and which is 4 bit. 4 bit, if something is there, it is called nibble, and if it is 8 bits, it's called 1 byte or 1 octet. So, what are the examples of binary? It is 1010, 0101. So, it's 8 bits of binary, and it collectively it's called 1 byte because it has 8 bits. A decimal is just a normal number 128, 127, 251. Example. Hexadecimal is FF, FF, FF. So, one single word here determines the 4 bits of value, which is a nibble, and two nibbles collectively called one hexadecimal number. So let's just understand how computer understand decimal. It converted it into binary and then it processed the data. So before going into the conversion, you just need to understand how this table has been formed. So what is this table about? For example, let's say if this is our device, or let's say this is a bulb. I'm taking an example, real world example as well. If it is on, that means it is 1 in binary. If it is off, that means it is 0. If it is any chip inside our CPU, chips I will say, if it is on or if it is off, it represents 1 or 0. Off means 0 and 1 means on. Let's say if only one chip is running, it has only two possibility, either it is 1 or it is 0. So that means only one bit output we are getting, right? If we have two chips, what are the output you can get? Either both are off, that means 0 0. If both are on, that means if both are on, that means, just a sec, I'll erase this because it should be 1. Yeah, if both are on, that means 1 1. If one is on, that means one is on. If the first one is on, then, so we have four possibilities here. So we are using two chips, means we are having four possibilities. If we are using one, we are having two. If we are using three, we are having eight. So like this we have 8 cable, 8 chips table, because this is how our this table is formed. So we need to by heart this table for conversion between binary and decimal number and decimal to binary. So let's just go and understand with an example. So now we'll do the conversion. First we'll do conversion from decimal to binary. So we have two methods for that. So we'll discuss method one first. And the example for that is 250 250 LB. So method number one says if everything is on, let's say this is one, 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 this is one. It will be 255, right? 11111111. This will be a 255. So but we have to convert decimal of 250 into binary. So 255 minus 250. It is giving 5. Means 5 I have to fill with 0, else I can mark it as 1. So we know our table is 128, 64, 32, 16, 8, 4, 2, 1. 5. How can I make it 5? This and this I can mark it as 0. And hence this will become our 11111010 will be our binary number. This is by method 1. Now if I talk about method 2 for converting decimal to binary. So by method 2 we'll do one thing. We will be filling 250 from starting from left to right. Okay. So 250 we have to fill, right? If I subtract 128 from it, it will become 122. So we have filled successfully this, right? So we will write it as 1. Now 122 minus 64. This will be 8, 11, 6, 58. This is also filled, so 1. 58, 32, again we can fill. So yeah, again 1. 26 minus 16. It will be 10. Again we have filled. 10 minus 8. It will be 2. Again it is 1. 2 we have. 4 we cannot subtract from 2. But 2 we can. So 4 is coming off. And 2 is 1. Once 2 gone, we have got 0. And but we have 1. So it should also be off. So yeah. This is our binary 111110. So I hope you understand. So 250 can be written as 51010. So this is a way how we convert decimals to binary. Now we'll understand how to convert binary to decimal. For understanding this binary to decimal, again have to follow the same table. For now understand we have the binary digit given like this 10101111. Again, we will refer this table. First one is 1. The first one is 1, right? Or we can go from left to right. 1 is 128 into 1 plus 0 into 64 plus 1 into 32 plus 1 into 16 plus 1 into 8 plus 1 into 4 plus 1 into 2 plus 1 into 1. When we calculate this, it will be 64 and plus 16, that is 80. 255 minus 80, 5. 175. This will be your 175 decimal number. If you calculate this, this will become your 175. So this is the way how we do these binary to decimal conversion. And you can also understand the first bit is 128, 64. So like that you can also do in mind. 1 into 120, 128, 64 is 0, 32, 32 plus 128, 150, 150 plus 16, 150 plus 166, 470, 274, 75, 175. So like this, you do binary to decimal. So if I take one more example quickly, we have to convert 129 to binary, and we have to convert 111 to decimal. 128. So we know first is 128. It is full. What about next? We cannot fill because we have get got one other here. So one only can be filled at last. So one, zero, all others off. It will be this. For this, this is one, right? And this is 1, 2, 3, 4, 1, 2, 4, 8, 16. 16. 16 plus 1, 17. 17 minus 255. It will be your 238. 238 is in decimal. And this is in binary. So I hope conversion of binary to decimal and decimal to binary is clear. Now we'll move to very important nowadays, which is utilizing in MAC addresses as well as IPv6 hexadecimal. Hexadecimal is represented from 0 to F. It is in two sets, 0 to 9 and A to F. A to F is 10 to 16, 15, and 0 to 9. It's the same as decimal. Okay, so quickly we'll see how to convert this in hexa. As I told it mentioned earlier, hexadecimal is component of two nibble. Two nibble, one nibble means four binary bit. Okay, so that means total hexadecimal is having two nibbles and one of four means in this format. Whenever we will do calculation, we'll do with 4 bits form. So if we got 129 as our, not 129, let's take little bit complex. Let's say we have 132 as decimal and we need to convert it into hexadecimal. So as you all know, it is consists of two nibbles, each of 4 bits form. Now for that purpose, we need to convert it into binary, and then we will convert it into hexadecimal. So how can we write 132 in binary? It will be written as 128 utilize here, 64 cannot utilize 0, 32 cannot utilize, 16 cannot utilize, 8, yeah, 8 can utilize 0, 0, 0. So this will be your binary. You can understand this by only remembering that table. I can convert this into a binary. You can do as well. Then we'll do partition for hexadecimal, and then we can refer this table. What is 1000 value? It is 8, right? And what is 1000? It's again 8. So 88 is the hexadecimal of 132. So this is the way how you do transfer, or this is the way how you will be calculating questions or converting the number systems, which are very important from a network engineer perspective. And I can give you one more example from hexa to decimal now. If something written as F8, how will you decode it in binary? So if it is F8, I know F is for 4 bit and 8 is for 4 bit. And how will you write 8 in binary? You will write 8. This is 1, 2, 4, 8. 8 means 1000, and it is F. F means 15. Means 1, 2, 3, 4, 7, 8, 15. So everything is 1, 1. So that means this can write as 1, 1, 1, 1, 1, 0, 0, 0. If it is like B, C, How to convert this hexadecimal into binary and decimal? This is the question. So B is for B is for 11, right? In decimal. And how would you decode this decimal in binary? 11 can be written as 8 plus 2 plus 1. 1, 0, 1, 1. And C can be written as 12. And 12 can be written as 8, 4, 12, 0, 0. So the whole thing will be converted as binary form. And if I add this up, this will become 23. I hope this is clear. So yeah, that is what needed to convert decimals. Here's the last thing I would like to add in this video. How our data amount going to measure with unit. So by which unit our data amount going to measure? It happens in kilobyte, megabyte, 1 terabyte, like this. This is bytes. Understand? If we are talking about speed, like by what speed our data is going or transferring, this happen in 1 kb, 1 mb. This will be in bits. So this is a difference between bit and bytes in terms of understanding their uses. So don't confuse between these two uses. If someone is saying the 1 megabyte amount of data has been transferred, don't understand it 1 megabit. Thank you for making this out. If you find it useful, please do subscribe and like my video. Thank you.